Hello everyone, my name is Xueliang. I present information strategic analysis of thyroid cancer risk data sets using the GIDT toolkit. Thyroid nodules are common but little malignant, so doctors combine demographics, lifestyle, exposure history, hormone levels, and nodule size to stratify cancer risk. Inside of fitting models such as logistic regression, I ask how much information does observed variable carry about the three-level thyroid cancer risk label. The data set has 212,000 691 patients and 16 variables, demographics, lifestyles, exposure, family history, and biological markers, uh, plus labels for three-level risk diagnosis. From this, I define field information segregate hypothesis. Each one is TSH carries the most MI and risk among TSH or T3 or T4. H2 is T3 still carries MI about risk after conditioning on age. H3 is biological features are more informative about risk than lifestyle and exposure groups. H4 is joint hormones shows a synergistic MI beyond the sum of individual MI. H5 is gradation exposure is more informative about risk when family history is positive. I dropped patient ID and keep all other variables. Age, TSH level, T3 level, T4 level, and nodule size are binned into four quantiles. Benny and categorical variables are called numerically. Risk is called it's called 0, 1, 2 for low, medium, high. Diagnosis is 0 for benign and 1 for malignant. MI measures how much knowing X reduce uncertainty about Y. Conditional MI measures information from X about Y given Z. I use this inside of correlation because they are model free and capture non-linears and higher order dependencies with GIDT's discrete MI and CMI calculators called from Python via JPYPE. I compute I of X and Z risk and I of X and Z and risk and Z for each hypothesis. For ATSH, I run a permutation test with 200 risk label sets to check whether the observed MI could risk by chance. For H1, the MI between the hormones and the risk is shown in the figure above. This indicates TSH is greater than T4 and T4 is greater than T3. Consistent with the intuition that TSH is a key indicator. So our values are only approximately 10 minus 5 to 10 minus 4 beats. For H2, the MI after conditioning on age increased by 5 to 6 times compared to unconditioned case. Indication that T3 provides information beyond what is explained by age. For H3, I group predictors into biological, lifestyle, and exposure. The average MI for each group is shown in the figure. Thus, biological is greater than lifestyle and lifestyle is greater than exposure. consistent with biological markers being more directly related to risk. But our averages remain in the 10 minus 5 to 10 minus 4 range. For H4, the combined MI is approximately 9 times the sum of the MI value for the individual hormones. The gender hormone pattern therefore shows the positive synergy, although the total MI is still far below 1,000th of a bit. For H5, I examined radiation exposure within family. When family history is positive, the MI carried by radiation exposure is greater than when family history is negative, but both values are extremely small. In this permutation test for TSH, the observed MI approximately 0.24 times 10 minus 4 bits lies well inside the distribution from 200 label sites with p approximately 0.36. There is no statistically significant association between TSH and the three-level risk label. Across all predictors, MI with risk is tiny, about 10 minutes 5 to 10 minutes 4 bits. Biological features rank slightly higher than lifestyle and exposure. And the joint hormone code shows the synergy, but all values remain far below the thousands of a bit. Together with the non-significant permutation test, this suggests that in this teaching test, the thyroid cancer risk label is most independent of the observed predictors. Maybe the synapse synaptic or driven by hidden variable and forbidden discretization alone cannot explain the near zero MI. In the permutation test for TSH, the observed amount of information falls thinly within distribution of the randoms label size with p equals 0.36. There is no statistically significant association between TSH and the three-level risk label. This project maps a clinical intuition into H1 to H5 use a consistent discrete encoding for all variables, applies GIDTMI or CMI estimators from Python, and is permutation testing. Limitations are that this is a teaching dataset, only discrete estimators are used, and the analyze considers a single static snapshot without temporal dynamics. Feature work to apply the framework to real hospital data. Try alternative discretization extend to time series. And this is the references. Thank you for listening.